The following podcast is sponsored by Structure Tech.
Somebody was looking for a good contractor, and they said, well, what's the good contractor for? And they said, well, I have this furnace that's backdrafting back down a water heater vent. Welcome, everyone. You're listening to Structure Talk, a Structure Tech presentation. My name is Bill Ulrich alongside Tessa Murray and Reuben Saltzman. As always, your three-legged stool coming to you from the Northland, talking all things houses, home inspections, and anything else that's rattling around in our brain. On today's episode, we're going to dig into carbon monoxide a little bit. And the reason this topic came up is because one of our inspectors was in a house not too long ago, and he noted some backdrafting at a water heater hood. And when this was happening, when the furnace turned on, and it didn't resolve quickly, which turned out to be a conversation topic on our internal communication platform. Somebody was looking for a good contractor, and they said, well, what's the good contractor for? And they said, well, I have this problem, 80% furnace that's backdrafting back down a water heater vent. And that led into this conversation about contractor coming out, who came out the same day we did our inspection and threw the inspector right under the bus. I mean, this was a Greyhound that met inspector at 65, just like they were standing in the middle of the interstate. So our inspector gets absolutely run over by a bus. The contractor says we're dumb. We don't know anything that we're talking about. And so I wanted to dive into this topic on today's episode and really try to deconstruct it. And this episode is going to air just after a horrible tragedy that happened up in Moorhead, Minnesota, where 7 family members all died, all perished in one house, presumably from carbon monoxide poisoning. And the verdict is still out if they did pass from carbon monoxide, but all signs are that it was the case. So, Reuben, Tessa, I am ready to pick your brains about combustion safety, carbon monoxide, what's right, what's allowable, what you as a person, as a human would say to another person who might be having this happen inside their house. So that was a very long introduction. I apologize for that on today's episode to talk about carbon monoxide, but let's do it. Reuben, you and I had this conversation offline, so you're somewhat familiar with what had happened here, but I'll summarize for Tessa because she's probably not in the loop on this whole thing. So Milan, one of our most senior people, is out in the field. He comes across this 80% furnace, and what 80% means is that it's not a high efficiency furnace, which means the exhaust gases go up a chimney through the roof to the exterior environment.
And let me take a minute to jump in there a second, Bill. Just a little bit more definition on this. We typically call them 80% efficient furnaces. Another way to refer to that would be a category 1 gas appliance. It's a little bit more of a technical term for what you're describing. And we're saying that the vent is going to be under negative pressure and there's no condensation inside the vent. You got those two things, and it is by definition a category 1 appliance. And it means that if you were to poke a hole in that vent, any air is going to get sucked into the hole. The vent is under negative pressure. It operates that way because the flue gases are lighter than the surrounding air. They rise up and out through gravity. So we're relying on gravity to get the exhaust gases out. And I know you said they get up and out of the house through a chimney, and it could be different things. I mean, one way, if you have a really old house, you might have a chimney, a masonry chimney in the middle of the home. And you may have a liner going up the middle of the chimney. You might also have a B vent. It's a double wall metal flue that runs up the middle of the house. You could be relying on that to take the exhaust gases out. And that's what you're generically referring to as a chimney, right, Bill?
Correct.
Okay, cool.
Pathway
cool.
to the exterior, but under gravity, right?
Yeah, exactly. So just for any word sticklers out there, I want to make sure we got our terms correct here.
For our technical audiences listening.
Exactly. Bill, I totally derailed your train of thought, I'm sure,
No.
but see if you can get back on it.
Yeah. And so Melinda's out doing the home inspection. And as everybody knows, if you've listened to this podcast, we test furnaces as part of the home inspection. Furnace kicks on. There's all of this hot air that's coming right back down the water heater vent, the hood at the water heater. Okay. So for everybody, if you can imagine this, there's a furnace sitting right next to a water heater. The water heater gases have to go up and out, just like the furnace gases have to go up and out. They merge together into a common pipe that goes straight up and out of the house. So when the furnace turns on, there's this thing called an induction fan that kind of helps expedite this process of getting the gases out, Reuben, correct?
Yeah, the purpose of that fan is to get the flue gases out of the heat exchanger for the furnace. A lot of people call this a draft assist fan or something like that, or induced draft fan. And yeah, it's true. It will induce a draft. It will pull the exhaust gases out of there, but it's not responsible for pushing those exhaust gases all the way to their termination at the roof. All it's responsible for doing is getting the exhaust gas out of the heat exchanger for the furnace. And after that, you're supposed to be relying on gravity. But let's all be honest, you put your hand above that thing, it's a fan blowing air. I mean, it's going to be pushing air against your hand. So I can see exactly how this happened.
Okay. And so what Melinda noted was this fan turns on, the furnace turns on, these exhaust gases go up the vent and all of a sudden make a left hand or right hand turn and go right back down the vent for the water heater and end up spilling back into the room. So much so, this was a brand new water heater. It had melted the plastic grommets by the two pipes that go into the water heater. Mm-hmm. So there's a hot and a cold that come out of the top of the water heater next to the hood. And they've got these fancy little grommets around them just for finish to make it look nice. It had melted that plastic. So Malin goes through and he tests it and he notes it and he takes a video of it. And he said, this is happening. It shouldn't come back into the living environment. It should go up the chimney. Get this looked at. There was enough exhaust gases being pushed back into the house where when he used his combustible gas detector, that thing is like pinging. It's saying, hey, there's stuff coming in the room. So he alerted the homeowner. They got a contractor out. Contractor comes out and says, I don't know what you're talking about. It's not a problem. Let's go on with your life. And that's where Malin kind of got put in the crosshairs because we called it out. Contractor says, not an issue, so on and so forth. Okay, that happened. Let's fast forward. Just talk briefly about this family, this horrible situation up in Moorhead, where 7 people perished, and presumably because there were carbon monoxide gases inside this house. So much so, they got to the level that, you end up kind of going to sleep and they all died, and it was terrible. That's what Malin was kind of calling out. He said, you don't want to have a situation where you've got these gases coming back into the house because it can be super dangerous. Now, I'm not saying one is analogous to the other. I'm just saying that's the worst case scenario. And that's why we call these kinds of things out. But what do we do in these situations? How much is too much, Tessa? And I'm gonna direct this question to you because you used to do this kind of combustion safety testing and analyzing and that sort. How much is too much coming back into the house as it relates to combustion gases?
That's a good question. And I think it depends on who you ask. How much is too much? I mean, there's definitely, Minnesota Fuel and Gas Code has its thresholds. BPI has thresholds, Building Performance Institute. In my personal opinion, any exhaust gas coming back into the house is too much. You don't want to have a backdrafting combustion appliance in your house. And so that could be anything like we've talked about. That could be a natural draft or atmospherically vented water heater. That could be a furnace that's commonly vented with a natural draft water heater, like a 80% induced draft furnace. That could be a gas fireplace. It could be a gas range or oven. It could be a gas dryer. Any appliance you have in your house that's using natural gas or, combustion could be a health concern. And I think it's something that, at least in the inspection industry, there's definitely a gray area. And Reuben, you can jump in and correct me if I'm wrong. It seems like it is this potential big health hazard for occupants, but there's no requirement for home inspectors to do a backdrafting test or even a combustion gas analysis on these appliances. Am I correct?
No, you're correct. And I've even sat through a number of continuing education seminars put on for home inspectors where the presenter told the audience, you have no business doing this. It's outside the standards of our practice, so don't even go there. I mean, I've been in classes where we were encouraged not to do it. Now, here at Structure Tech, we do not subscribe to that. I teach home inspectors the opposite. I say do more. Because when you're saying you're not going to do this, it's all about just trying to stay in your lane and minimize your exposure and just say, this is exactly what I do and that is all I will do. But that's not doing any favors to your clients when you do that.
And the majority of homes that we're inspecting here do have one of those types of appliances in it. Occasionally you run across a new construction house that has a high efficiency furnace that has an intake and exhaust pipe that are ducted directly to the outside, and they've got an electric water heater or power vent water heater, and they don't have these gas appliances that you need to worry about combustion safety with, but the majority of houses do. And I just think it's such a disservice to homeowners to just skip over that potential big health hazard during inspection. And it is difficult because the methods for testing are pretty complicated. There's a lot of variables. And Reuben, you just sent us, what was it? The Minnesota Fuel and Gas Code. What is it? Appendix D.
That's right. And for anybody
about how to test.
And for anybody outside of Minnesota, if you're just using the regular IRC, the International Residential Code, it's still Appendix D. I don't know what version different people have, but in the 2018 version, they call it Appendix D. You turn all the way to the end of the IRC, and you can find that same standard. And it's not part of the code. These are not requirements, but it's some really nice procedures for testing fuel gas fired appliances for safety. There's a lot of stuff in there.
And you're going to link that up, right?
Yes, we will put the Minnesota version of that in the show notes.
And then this other, Building Performance Institute, they also have testing procedures for how to do what we would call a worst case depressurization test to see if these combustion appliances are going to be spilling, combustion gases back into the house. And there's a lot of similarities between the two. I haven't read in depth each step by step to compare, but it's a complicated process. And, I come from this weatherization background where I used to do a lot of energy audits, and part of that process is doing this worst case draft testing in these houses where you're going to go in and you're going to make improvements to the building envelope. You're going to make it more energy efficient. You're going to add insulation. You're going to do air sealing. You're going to add continuous ventilation. All of these things can impact how a combustion appliance, like a natural draft water heater, vents. And if you add a continuous run bath fan, you could potentially cause a water heater to backdraft. And so that was something that we would do with every house we would go into, is this testing procedure to see if these appliances are drafting safely. And it's something, though, that you really don't see being done, I don't think, in really any other industry. And Bill, as you were describing how this contractor came in and just kind of threw our inspector under the bus, I think it's important for a lot of homeowners that might be listening out there, a lot of contractors, HVAC contractors or plumbers, don't understand what we're talking about, and they certainly really don't know how to do this type of testing procedure. Am I overstepping my bound by
totally
saying that?
Agree, Tessa. And I'd say that this is part of the reason that a lot of educators in the home inspection field will encourage home inspectors to not do this because of exactly what just happened to us the other day. And they say, I don't know why they say it, but the way I feel is that they're saying, just don't do any of this so you don't get in trouble. And who cares about all of these hazardous appliances that you might be missing? That's what I'm hearing when I hear people say this.
Yeah, it's people are afraid of the additional liability and potential, complaints that could come across their plate if they do this. And since it's such I feel like it's such a complicated area that a lot of other contractors don't want to venture into it either.
This is exactly why I want to have this conversation, because this is an imperfect thing. This happens for a period of time and then it goes away. And Reuben, 1 minute, 2 minutes, 5 minutes, Tessa, Reuben, we were kind of talking about this before the podcast. How long is it acceptable to have this condition present in the home before it resolves and moves on? A range. When I was doing research for this podcast, since 1926, it's been acceptable for ranges to emit up to 800 parts per million of CO into the house. Now, we will link where I got this information, but it's from an appliance website, like a research website out of Canada. But most of those appliances can be tuned down to something like 50-ish, right? But the standard is very high of how much CO can be allowed in the house. Now, presumably you don't run your range continuously and you don't heat your house with your range. So this is a situation where there's a whole bunch of CO coming in and then it goes away because you stop using it. Just like when the furnace starts up in the event that Malin noted, that resolves in a period of time. So what we're talking about is dangerous situations, but then they go away. I'd
say maybe, Bill. I mean, we are pretty picky about how we do these tests. I mean, everybody knows that if you've got a cold, I shouldn't say everybody, I'm telling you right now, if you've got a cold vent, it's a cold day, it's 0 degrees outside, and you've had cold air spilling down into that vent, that whole vent is going to be really cold. It's going to be relatively heavy air. And when you first kick on the burner on that little water heater, a little 40,000 BTU water heater, it's not a ton of heat. And it's going to take a while for that vent to warm up and have the buoyancy of those hot gases overcome the weight of that really cold air dumping down your flue. It's going to take a little while. Initially, when you first turn it on, you got a cold flue, it's going to backdraft. We understand that. And that's normal. It happens. I mean, Tessa's saying she doesn't like to see it at all. I agree. I don't like to see it at all either, but it's just a fact of life. It's going to happen. We all understand that. But, your question, Bill, is how long is acceptable? How long should you let that thing backdraft before it's a problem? And it depends on which standard you're looking at. If we look at BPI standards, Building Performance Institute, the one that Tessa used as a weatherization contractor, it was 60 seconds. You fire up that appliance and you give it 60 seconds to begin drafting properly. And that's what we do too. I mean, here at Structure Tech, we're not going to just put our hand right there and say, oh, it's backdrafting and write it up. No, we always got to give it time to make sure that it has the ability to establish proper draft. But if you look at other standards like this Appendix D in the IRC, which again is not code, it's just a suggested way of testing something, they give it up to 5 minutes to establish draft. I think that's a little crazy, but that's what the standard is. And I believe that comes from ANSI standards. I believe that is the ANSI standard for how long it can take to establish proper draft.
And I'll just add something real quick. There might be some variables that I'm unaware of that have changed with the BPI testing in recent years that have caveats for when you do that spillage test on if it's a cold vent or a warm vent or something like that too. So, but yeah, there's these different standards that have different kind of time limits on when that backdrafting can kind of self-correct. And I'd say though, I don't like seeing any combustion gases coming in, but typically you'll know in the first minute of testing spillage if that's going to self-correct and start venting properly or not. And if it's still backdrafting very strongly after a minute or two, then typically that's when I note that as being an issue.
You guys have seen enough of these melted grommets that I explained, and oftentimes it's an old house, it's 2 stories plus, it's a tall chimney that's on the outside of the house, right? There's a lot of Mother Nature working against the design of heating up that flue quickly, right? And that's kind of the common tracks that you see on those situations.
That's a good point that you bring up, Bill. Like, what are the signs of a backdrafting water heater? Like, what are the things that you see or that you can look for? I would say it doesn't necessarily have to be a 2-story house or a really tall chimney for that problem to happen. Like a lot of these variables that can impact whether or not, like a natural draft water heater is going to vent properly are basically just pressures in the house, pressures on the house. What's the temperature outside? What's the temperature inside? Is there wind? Do you have a lot of exhaust appliances in the house that are sucking air out of the house, like dryers and fans and kitchen hood vents that create a negative pressure in the house that cause that water heater to struggle to create a proper draft? Is that water heater vented by itself up through a chimney in a metal flue that's sized for a furnace and a water heater? Is it orphaned? That's another word that we can use in the industry to describe that situation. Or is it venting with the help of a furnace? A lot of those factors can impact whether or not an appliance is going to draft properly. And, those variables are constantly changing. People make changes to their house. They make their house more airtight by doing some air sealing, by replacing old windows. That can impact the water heater draft. Lots of things. Adding a radon mitigation system can change pressures in a house and cause a water heater to backdraft. So there's a lot of different things. And depending on kind of what time of year you're testing, how you test, you can get different results. But, I don't want to freak homeowners out. I think a lot of times you can kind of, personally, I think you can look for some telltale signs of a backdrafting water heater. You don't have to be a specialist to do that. You can look for those, melted plastic grommets, like you said. You can look for rust around the top of a water heater. Another thing you don't want to see a metal vent for a water heater that has a negative pitch to it, right? Or you don't want to see a disconnected vent. So those are just some kind of basic things. You could even have potentially like a blocked vent if you've got a bird's nest in the chimney that can cause something like this to happen too.
That's what I was thinking was happening with this situation that I was describing with Malin, only because these appliances were so close to the chimney. Everything about this was designed to work well. There weren't all these unusual circumstances that you're like, oh, well, that made sense. It didn't make any sense that these gases were coming back in the house, which is why I thought it was kind of an interesting conversation. And I should be clear, this configuration that we're talking about, it's on the way out, because most people are replacing older appliances with newer, higher efficiency appliances. That's why we end up with orphan water heaters. You have a naturally vented water heater and a naturally venting furnace. Well, the furnace goes down and they replace it with a high efficiency, which is now doesn't need to use that chimney anymore. It goes out, the gases go outside the house, inside their own, venting system. And so this is a unicorn that's becoming less and less common, but it's still out there. It's never fun when we have people who really understand. Malin knows what he's talking about. This is not his first go around at finding this. And he's not an alarmist by any stretch of the imagination, but you just kind of feel bad where you find these things that are somewhat scratch your side of your head and you're like, this just doesn't feel right. It doesn't seem right. And it gets dismissed out of hand. Like, oh, this person doesn't know what they're talking about, and on and on and on. So
I just had a funny thought as Tessa is going through all of these potential situations that could cause it to backdraft. And I'm thinking about things that might change from the day that we're there to the day that the next person comes out. And it was just a week or two ago, right around the time that you're saying that this problem happened, where we had some, I don't know, near historic wind events in Minnesota where it was just ridiculously windy. We had like 60, 70 mile an hour winds. And that could be enough to cause an appliance to backdraft. You get the right wind pushing against the vent hood or changing the pressures inside the house, that might cause something to backdraft too. And I could see where we're out there doing the inspection. You got some crazy wind, it backdrafts, and somebody else comes out the next day. It's a nice calm day and nothing's going on. That could have happened too.
Crazy stuff. Hey, Reuben, I wanted you to touch on something because you're good at explaining these sorts of things. referring back to this tragedy in Moorhead, I went to the paper, I read about it, I found the address, I looked up the house on Google Earth. It's a new property. This is what's so unusual about this. This place clearly has a high efficiency furnace. And what's the difference between a high efficiency furnace in this? Because you talked about a negative pressure earlier with the 80%. And so is there something different about a high efficiency where it would be an unusual situation to have a power vented water heater in a high efficiency furnace where there's a ton of carbon monoxide that has the ability to, get back into the house?
It's pretty unusual to have a problem with that because, those are more technically categorized as a category 4 appliance. And it means that the vent is under positive pressure. You poke a hole in that vent and whatever's in there is going to come out. And it's also a condensing appliance. It removes so much heat from the exhaust gas that you end up with condensation and you end up with condensate in the flue. So for one of those category 4 appliances, the potential to have carbon monoxide leaking into the home, to have backdrafting and any of that, it definitely does go way down. But it's not to say it can't happen. And even if it's new, I remember there was a new construction home I inspected. I won't say the city because I don't want to throw the building official under the bus, but it was a new construction home. And I remember smelling a funky odor in the basement. I knew it was carbon monoxide or exhaust gas. And I ended up getting up. I followed the furnace flue. I followed the water heater flue, both PVC plastic, high efficiency appliances. And I found a joint that was improperly glued and it completely separated up in the ceiling space.
Wow.
I had to kind of shine my light above a finished area to see it, but I just went, holy shnikes.
Oh
No wonder why I'm smelling this. And it could very well be something like that, where somebody didn't glue a joint together right.
But Bill, actually, I just to add to that, I think I read too, since it was a newer construction townhome that had like the furnace room. It didn't have a basement. It was slab on grade. It had basically a garage on the main level, and then the living space and bedrooms were above that. Right. And so they were thinking it could have either come from the furnace or potentially a vehicle. And that's another thing, another source of carbon monoxide we didn't talk about, but tuck under garages. If you've got, leakage happening between the garage space and in the living space, you can get exhaust gases in your home too, which is not a good thing.
Yeah. Looking at this house, there's the garage, as you said, on the main level. And then there was actually some living space on the main level as well. Okay. And then there was clearly living space above the garage. I just was thinking, how crazy would it be if you had a car, right? And you have a car starter on all these newer vehicles. And what if somebody accidentally starts the car? It's in the garage. The doors are shut. Your car's just running in the garage. And I'm way out there right now. So I'm way out of bounds and I know it, but it's just there's something unusual here that's going to be explained in the next little while. That's going to be really unfortunate. And carbon monoxide is a dangerous thing. And we should link up some of the better resources that we've kind of come across having this conversation to the podcast here. But all these different testing agencies, if it's OSHA, if it's ASHRAE, if it's BPI, they all have different standards. And they have standards that are like exposure for a short period of time that resolves, that you can do one level there, and then it's exposure over a long period of time, and that's a much different thing. So we will link that stuff up and people can go and kind of see the difference in it.
Something that everybody says universally is make sure you have carbon monoxide alarms installed. That's a really important part of this. And at this house where these people died, they found a carbon monoxide alarm sitting on a shelf with the batteries removed.
Mm-hmm.
These are life safety devices. I don't know what else to say.
Unfortunate.
One thing I think we've talked about before in past podcast episodes, but just to kind of refresh people, if you have a high efficiency furnace, as Reuben mentioned, it would be very unlikely that you would have carbon monoxide coming from the furnace back into the house unless there's a problem with the vent, like the vent is disconnected. But you could also potentially have carbon monoxide getting into the ductwork and circulate throughout the house, potentially if you have a cracked heat exchanger in the furnace too. But you would also need a furnace with a cracked heat exchanger, and you need a furnace that wasn't operating properly that would be creating a high level of CO in the exhaust gas to create a deadly situation. And
That's right.
furnaces, if they're running properly, should not be creating high amounts of CO in the exhaust gas. So that's kind of, a lot of unfortunate things would have to be happening for that situation to occur. But I think that's another important reason why we test the CO in exhaust gases for furnaces with our inspections to see if it's operating properly. And there's a lot of, inspectors that don't do that, and we're not required to from our ASHI standards that we follow. But I think it's a good idea to do that to see if it's operating properly. And I'll just add, this is something that I would like to do when I was out in the field. If I did find like a natural draft water heater that was backdrafting continuously, I would like to just kind of test the exhaust gases on that too with my combustion gas analyzer, just to see, was the CO really high in that exhaust gas or was it lower? And I'm not saying that it's okay to have low CO and have a water heater backdrafting. I just kind of wanted to know on the spectrum of backdrafting of how much CO is actually coming back into the house. And every once in a while, you'll run across a water heater that has 100 parts per million of CO or more that it's producing coming back into the house. And in my mind, like that's an even more dangerous situation than if it's producing very little CO.
I can imagine how that happens, though. You have some old water heater that's rusted on the bottom. Maybe it's in there's flakes of metal that fall down on the burner and the flame can't burn efficiently, right? Like Reuben, you did this with a furnace. You obstructed a flame just for fun to see how an obstructed flame would burn or
all the time. I would always do that with people in training. We'd have a traditional furnace fire up, and then I'd take my putty knife and I'd stick it in one of the burners. And then we'd watch the CO level skyrocket on our combustion analyzer just to show how much this flame impingement affects carbon monoxide levels.
Yeah, but I think, usually the biggest source of carbon monoxide into a house that's dangerous that I've seen, you can have these natural draft water heaters that are backdrafting, or on a rare occasion, a furnace that's producing high CO that, could be leaking in CO into the house. But I feel like ranges, like gas ranges, are potentially the biggest source of CO most commonly in homes because they are designed to vent the combustion gases into the house.
Yes.
So anytime you've got your oven running or your burners on, that is coming back into the house. And actually, so the place I'm living at has a gas range, and whenever that thing is on, I make sure that the exhaust vent above it, which is tied into a microwave, is turned on. And even when that is turned on and it's running the entire time, I'm at a really high speed that basically prevents anyone from being able to talk in the same room while it's running.
Yes.
I still get low levels of CO in the house. I have a personal CO monitor that I used to clip on my tool belt that I keep. And then I have the low level CO detector as well. Yep. And they will read anywhere from like 0 to 5 parts per million. I found that if I keep the fan on high, usually it stays at around 0. But if I don't keep the fan on, it can go up to 5 to 7 parts per million in the living room after just a short period of time without running.
Now, let me ask you, have you done a combustion test on that range? See what's coming out of that vent?
I'm afraid to do that. No, but I should. And you're talking about where the back of the range, where like the flat top meets the back of it, right? Where there's an opening and it vents.
Yep.
Yeah. I have not done that, but I wouldn't be surprised if you get a couple hundred parts per million.
Like Bill said at the beginning, and that number sounds right to me. I seem to remember that's what the standard is, 800 parts per million, which to me, it just seems crazy.
It's a big number for, I thought I was misreading something. I thought it was some other calculation, because when we talk about over 400 parts per million in a furnace is getting red tagged at if a contractor comes out and notes that, they'll red tag a unit like that.
Yeah. And that's for exhaust gas that's supposed to be leaving the house.
Right. Right. Not venting back into your face. I just think it's so important. And this is another thing that blows my mind. It's not a requirement to have an exhaust fan that vents to the outside above a range like that. And so, if I'm inspecting and I see a range, gas range, any range, actually, you should have some sort of ventilation, even if it's electric too, to get all of that, all the pollutants out of the house, I always make that recommendation to add a vent fan that vents to the outside. And also, a lot of older houses don't have vent fans, or they don't vent to the outside. They'll put in recirculating fans. I usually take some time just to talk to the buyers of the house and let them know, hey, if you're going to be cooking, make sure you crack a window just to get some fresh air in and get this combustion gas out of the house.
Yeah, those recirculating fans. Who came up with that? Seriously.
It's a joke.
What are we doing? You make it hard to talk, and that's all.
I know, but so many people are not aware of that potential health hazard and that safety concern, and Thanksgiving has a reputation, turkey, I think, gets blamed a lot for making people sleepy. But what if it's the fact that we're running our ovens all day, and if it's gas, they're just pumping CO into the house and making people sleepy because of that.
On top of the 4 Coors Lights you had before dinner and the wine you had with dinner.
Exactly.
On top of all of that. Oh, no, right. It's the tryptophan and the turkey. Yeah, it's
the tryptophan. We'll blame the turkey.
Yeah. Tessa, you're going to start a controversy across this nation about why people get tired.
Maybe it's a little bit all the above. Again, make sure you're running your exhaust fans when you're cooking. And if you don't have one that vents the outside, crack a window.
I think one of the things for me that I wanted for Malin and for this client was somebody who understands what he was saying was the concern, to actually come out and do a thorough analysis, right? This contractor came out, they did what they called a lighter test. I don't know what that is, but it feels like it was just a quick and dirty and we're out of here, nothing to be concerned about. And I just think it'd be nice if there was some resource that homeowners could be like, hey, can you really check this out and make sure it's all good? We don't have that currently.
Well, I could just share what we do as home inspectors when we're testing these appliances, because we've got a standard that all of our home inspectors follow. And it's that when we get to a house, we're going to make sure that all the windows and doors are closed. If there's a wood burning fireplace, you make sure the flue's closed or the damper is shut. If there's glass doors on the fireplace, close those, kind of simulate what somebody's going to have during the winter. Turn on all the exhaust fans. That means the bathroom exhaust fans, the kitchen exhaust fan, assuming it goes to the outside, the clothes dryer. That's going to be a semi-powerful motor on there. Turn on all the stuff that's going to be fighting for air, and then go and turn on your weakest appliance. It's going to be the water heater, and make sure the water heater drafts under those conditions. And if it does after 60 seconds, great. If it doesn't, go and open a door or a window and see if that changes it. And if it does, it tells you that you don't have sufficient combustion air. And our recommendation is get an HVAC contractor to fix the backdrafting and tell them, look at combustion air. This is a good way to good start. We don't design the repairs. We don't say have an HVAC contractor install this size duct. That definitely goes outside of our lane. But we like to give somebody a little bit of direction and say, hey, when we did this, it began drafting properly, just so that when the next person is coming in, if it's somebody like the person you were describing, Bill, how they may not know enough to do all of this extra testing and they don't have a good understanding of it. We're not trying to be know-it-alls about this. We're trying to help people get the right repair. That's really what it comes down to. So it's more text that the next person might be able to read and figure out how to solve this problem.
We are oversimplifying it. I know with BPI standards, they open and close all the interior doors and measure the pressures in each room to try and get the utility room to as strong of a negative pressure as possible and test it under those conditions, and running the furnace blower fan to create a stronger negative pressure. And if it does, keep it running, making sure ideally you want to test that water heater vent when the furnace has not been running, if it's commonly vented, so that it doesn't have the help of the furnace to start it, the draft properly. So there's all these caveats, but like Reuben, like you said, just to highlight it again, you put the house in a negative pressure as best you can by turning on all the strong exhaust appliances, making sure all the windows and exterior doors are closed, and then turn on that water heater, hold your hand up to that flue at that little gap between the top of the water heater tank and the flue itself, and see if you feel any hot air coming back out with all those exhaust appliances running at the same time. You can use your hand, you can use smoke stick, you can hold up a mirror to it. There's a lot of different ways. Personally, I can just use my hand and feel that exhaust gas coming back out. So anyone can do that. Any homeowner could try and do those basics just to see. But again, just be aware there's a lot of caveats and a lot of variables that can change the results.
Maybe, Tessa, you should start, like a to-do after a podcast. Give an assignment and see if all the super smart homeowners can go figure this stuff out just based on your words.
Well, for those people that really want to test this out and they want to have the details for the proper procedure, you can just Google BPI worst case draft or combustion appliance safety testing, and you can find the process for that online. You can follow that to a T, or Appendix D, as Reuben, as we'll link to as well, for testing procedures. But it can be a little bit overwhelming. And so I would just say, for anyone that's out there that's concerned about this, take a look at the top of your natural draft water heaters. If you see any melted plastic, that's a telltale sign. You can try and do the worst case draft test. If it turns out you do this test and you're pretty certain you've got a water heater that's backdrafting and it is an issue, what do you do from there? And there's a few different options. As Reuben said, sometimes it's just an issue of not having enough makeup air or combustion air. And it could be as simple as, adding a combustion makeup air if your house doesn't have one. But a lot of times I think the safest resolution for this potential issue is to get rid of the natural draft water heater. And I know there's going to be pushback from that. And there are certain situations where that may not even be possible based on, the location of the utility room and access to, getting a vent installed to the exterior. But in my honest opinion, when you've got a house that has a natural draft water heater that's backdrafting, this problem will probably only get worse with time as different people move into this house and make changes and make these, potential energy improvements. If they're going to do some air sealing, they're going to do insulation, they're going to add more ventilation, they're going to replace the induced draft furnace with a high efficiency furnace. All these energy improvements potentially make that water heater have an even harder time drafting. You're making the problem even worse. And so the only way to really guarantee you're not going to have a problem is to put in a type of water heater where you don't have to worry about that issue. And so that would be either like power vent water heater or an electric water heater. Those are kind of the two safest options. Reuben, I know you have an opinion. What do you want to say about that?
Well, I think we've talked about this on the show before. I mean, you're so totally over the top with this, but no, I'm giving you a hard time. No, you're right. That is the safest option. I can't argue with you, Tess.
Long-term investment for your safety.
Yeah. I mean,
you don't ever want to have to worry about it, and you want to sleep at night knowing it's not going to be a problem. That's what you can do. Yeah.
You're right. I would be much more inclined to focus on the little stuff. Like, can I change the configuration of my vent, maybe add more combustion air, make sure that I've got the right flue cap at the exterior so wind isn't going to push the exhaust gases back down, and make sure that I have properly working carbon monoxide alarms in a few different areas of the house. I'd be more inclined to do that.
There you go.
But you're right. What you're suggesting is the safest way to do it.
Well, and if you're on a budget and maybe it's not backdrafting all the time, just some of the time, you can do those things that Reuben just mentioned too. I think the most important thing is get yourself some good working CO detectors. Make sure they're installed where they should be in your house.
Yep.
All right. Well, let's leave it at that. We'll wrap up. Thank you guys for your opinions as always. And check your batteries and your carbon monoxide detectors and just make sure everything's working. And if they're old, update them. All right. I got the thumbs up. So we're going to put a wrap on this one. You've been listening to Structure Talk, a Structure Tech presentation. My name is Bill Ulrich alongside Tessa Murray and Reuben Saltzman. As always, thank you. Have a great day.
For more information on how we can provide you with the right information about your home before you buy or sell, contact us at structuretech.com.